Hello and welcome to the next session in your pathology series. This is Sri Kumar, Professor of Pathology and Director for Research and Postgraduate Studies in Masa University, Malaysia. In the previous session, we actually discussed about various aspects of abnormal growths in the cell. And in this session, we're actually going to discuss about how substances accumulate in the cell. It could be either products of the cell or it could be pigments. And this could be both normal or abnormal as well. So when something accumulates inside the cell, a cell actually will start storing various substances in the cytoplasm. And this is a way in which a cell adapts to injury. Now, normally a cell does not actually store any substance. The cell, actually its function is in metabolism. But however, when there is any condition where a cell can actually start storing substances, it means that there is an injury for which it is trying to adapt. Very simple. I would like to use the analogy of how when we get stressed up, when we are going through some trouble, we tend to eat a lot, store more food in our body. The same thing happens to the cell. When it undergoes any stress or any injury, it tends to eat a lot. And this is a simple analogy. When eating, it actually starts storing substances in the cytoplasm. Now, what are the substances that can be stored in the cytoplasm? It could be anything ranging from byproducts of biosynthetic products processes that you see normally, or it could just be something normal, such as water or lipids or proteins or even carbohydrates. So what if something accumulates in the cell? What happens to the cell? Well, actually, intracellular accumulations don't harm the cell. They just show that the cell is not functioning properly. For example, when lipids accumulate in the hepatocytes in an alcoholic liver disease, it actually shows that there's more amount of fat that's accumulating in the cell. It does not prove harmful to the cell, well, at least in the early stages. Now, at the same time, remember that as the accumulations increase over a period of time, it can actually contribute to disease. For example, in conditions like hemochromatosis, excess iron gets stored in the body in the various cells, and this causes damage to the cell. In diseases like gout, excess uric acid accumulation causes crystals to form, and these crystals become tophi or a granulomatous inflammation. Accumulation of a type of protein called beta amyloid, which is seen in Alzheimer's disease, and so on. Now, an accumulation can be endogenous when it is from inside the body, or exogenous when it is from outside the body. And whether it is endogenous or exogenous, it could be normal or it could be abnormal. A normal endogenous is one where the accumulation is at a normal rate, but the cell does not have the adequate metabolism to remove it. The best example is fatty change in the liver. The fat is produced in the normal pace, but the cells do not have the capacity to remove the excess of fats. When protein goes through the glomerulus and the tubule reabsorbs the protein. When excess of protein goes through, there is excess of reabsorption of protein, and this is seen as tubular protein droplets. Abnormal endogenous products are usually seen as breakdown products. It could be due to any defect in metabolism or transport or secretion. Exogenous can be normal when they are pigments. Pigments can be transient or permanent, or abnormal when the person is exposed to carbon dust and the excess of carbon goes inside and it accumulates in the body, in the lungs, or infectious agents produce certain toxic substances which accumulate in the body. So among all these, the first example that I'm going to discuss today, and the most common example and the most important feature, is fatty change. Now, fatty change is a condition where there is a metabolic derangement which is not lethal, which means it is not fatal. So there's accumulation of triglycerides within the cells which help in fat metabolism. Which are the cells that help in fat metabolism? The liver, the myocardium, and the kidneys. So when fat accumulates in these, there is excess amount of fat within the cytoplasm, pushing the nucleus to the side. Now, to understand this, let us actually first see the metabolism of fat. Now, this is what happens in the liver. Free fatty acids get converted to fatty acids. Now, normally fatty acids move on to get converted to triglycerides. However, it also undergoes oxidation to ketone and with the help of phospholipids and gets converted to cholesterol esters. Triglycerides go on to get converted to lipoproteins, or with the help of acetyl-CoA, they get converted to apoprotein. When there's any deficiency in this step or in this step, there is excess of this, and there's lipid accumulation. Now, these are the metabolic mechanisms where there is a deficiency in any of the steps. When there is increased peripheral mobilization of free fatty acids, these free fatty acids are increased in the periphery, so there is more fatty acids in the liver. So more fatty acids are taken into this liver. This is seen in diabetes, starvation, and increased ethanol. Ethanol is alcohol. The next is increased conversion of fatty acids into triglycerides. Increased conversion of fatty acids into triglycerides. This occurs when this step is less or when this step is deficient. This again is seen in excess alcohol consumption. The third is reduced oxidation of triglycerides to acetyl-CoA. So increased triglycerides. This is seen in hypoxia, toxins, and ethanol. So reduce oxidation of triglycerides to acetyl-CoA in the presence of apoprotein. So there's more of TGL and it increases the lipoproteins. And deficiency of apoprotein. So there is impaired export of triglycerides. This is seen in malnutrition and toxins. So there is a deficiency of apoprotein. So there's reduced movement of triglycerides to acetyl-CoA. So there's an increase in lipoproteins and increase in lipid accumulation. So these are the 4 metabolic mechanisms which we have seen in this slide, and I have also compared it in the previous slide at each level for your easy understanding.